Precision, realism, and foresight. These are what make high-performance vehicles competitive at the highest level. Today, simulations go far beyond analysis. They become a core part of development, shaping how cars behave before they even hit the track. In Dynamis PRC, the Formula student team of the Politecnico di Milano, we strongly believe in modeling and strive to make the most of the MATLAB Simulink environment. In the past years, we have developed separately a double-track-based driver-in-the-loop system, presented at last year's challenge, and a hardware-in-the-loop electronics components test bench. So, the question was obvious, why not combine them? And here's the challenger for 2025. A SpeedGoat performance target machine allows the team to run a heavier, but more accurate, multi-body model and to emulate the high-voltage system of the car. Now, the real car's electronics interact with the simulator equipped with the car's input devices and capable of 3D tracks rendering. The immersion level is further increased, allowing for deeper and more accurate early season analysis. Moving on to the project, here is its structure. A target model runs on a SpeedGoat machine and deals with the vehicle dynamics and the necessary electronics component simulation. The host model runs on the simulator computer and features the graphical part of the simulation and the driver inputs acquisition. The two models communicate using UDP protocol implemented with designated blockset for SpeedGoat target machines. As for the target machine, in the electronic subsystem, the accumulator and the motor's inverters are simulated, and the model outputs are sent to their relative boards over the CAN bus. The battery model features the thermal and electric simulation of the cells, emulating the current and insulation sensor present in the real accumulator. The inverter 1 instead uses Simulink charts to emulate the inverter's FSM, giving back to the system the required feedback for applying motor torques. Real cars DBCs are used for messages definition, allowing complete emulation of the boards and sensor behaviors, and granting communication with the other real-life boards placed in the hardware-in-the-loop test bench. The multibody subsystem is the physical model of the car, and is made with Simscape Multibody. It's based on self-developed library that includes many custom blocks, allowing maximum flexibility. Compared to the double track, it features a more realistic simulation, thanks to the high number of model components and degrees of freedom. The model can now run on full 3D tracks, with the road surface imported as a point cloud and a real engine used for graphical rendering. This represents a significant advancement, enabled by dedicated updates both to the ride height calculation and the tire block, which have been adapted to meet the specific requirements of three-dimensional tracks. The SpeedGoat machine is connected to the hardware-in-the-loop test bench, consisting of real steering wheel, cardboards, and connections. The two systems communicate through 4 CAN channels, available thanks to the dedicated SpeedGoat expansion board and the relative Simulink block set. For example, AMS, the accumulator management system, uses accumulator data coming from the battery model, while VCU, the vehicle control unit, uses the car data to run the torque vectoring algorithm, which is also built thanks to the Simulink embedded coder to calculate the torques that will be sent back to the target model. The connection with the steering wheel means that the track procedures can be followed, which is fundamental for immersivity and driver training. Then, the host model is introduced. It represents the connection between the simulator and the target model, handling the driver inputs that are sent to SpeedGoat and receiving feedback on the vehicle behavior. This information is then used to enable accurate graphical visualization through new, more realistic sceneries developed with the Unreal Engine environment. Overall, this work represents a significant step forward in our development process. The effort invested is already proving valuable through new extensive testing and validation activities. The next step happens on track. See you there.